Um, Thanks, Shannon, for organizing efforts, keeping us in check. It's a bit of homecoming for me. I worked for TT a long time ago, and also we presented at this conference in 2013 and 14. So that was back then on a concept of a building API and on getting real-time data out of building management systems. And what we have today is basically, it's a recap, summary, update on those efforts which are all in production now. So we have a dirty IoTini, and it's one part connected devices, one part cloud orchestration, 8-part project management. And it's a bit of a, it's meant this way. You think the barrier of entrance for IoT is really low, right? I mean, all you need is $20 for a Raspberry Pi and a little cloud, and you're off and running, and you're an IoT company. And we kind of learned, not the hard way, but in an honest business way, how that's not quite the case. I'm also still thinking about this layer thing. I really like that. I wonder if, sometimes you watch these big blockbuster movies nowadays, and at the end of the movie, they have like 10 minutes of credits and $500 million of budget. And you're like, they set up like multiple companies, whole industries are spawned just around operating and making one movie. And I felt with this layer thing, it's like when are we gonna have integrated project delivery where you spawn this whole thing, including an R&D department, including an IT department, to operate projects, because we're not doing that. But that's how we actually could do innovation in the whole life cycle of a project, rather than, oh, here's all the stuff we do at ET, and here's all the stuff they do at Skanska. And so that's the next slide here. It's a bit obvious. There's an A in ESC, there's an O. Jonathan just pointed out the O's on the slide here on the AEC conference, the O's on it. And so why do we do technology, and who's doing it, and for what, right? I mean, obviously, we're geeks. I do technology just for the love of it, I mean, you give me any problem, any industry, I'll love to play with new technology. And so in architecture, you have realize organic visions. In engineering, you keep up with it. Automate compliance is a common topic in both industries here, architecture and engineering. Automate compliance is rule checking, basically. All this spawning of automation around rule checking and design. There's no innovation in making a beam work in a building, right? That's just stupid rule checking, so we automate that. So a lot of simulate now, simulate egress in architecture, simulate structural performance, for instance, in engineering, and then interoperability, of course, is a very driving force of why we do innovation in technology. And then you kind of like drop it, because then construction starts and they do something completely different, right? They want to not get sued, deliver on time. It's a lot of risk management. I think safety used to be like a big, catchy application for BIM, and I think that's just brainwashing. I don't know anybody uses BIM for safety. But mostly it's about coordination and nowadays lots of fabrication. And I think where the trend should be going, or will be going more, is using technology to improve the orchestration of supply chain and construction. There's still a lot of manual stuff, a lot of like driven by Excel. And then the big O, I think it's all there and all wants to be done, but none of it really is done. The first point here, CMMS, computerized maintenance management system, that's your Maximos. There's a lot of like really expensive dinosaur applications that don't have APIs, there's no interoperability. They don't spawn these systems out of engineering, design, and construction. They're built after the fact. I think that hasn't changed. Performance monitoring, if you go to more industrial places, industrial IoT is a big word there. So taking like data out of like building management systems and doing something with it. That's not done much either. Continuous commissioning is curious, right? Because you're not even allowed to say it without saying that, yes, it's a proprietary term that got copyrighted by Texas A&M. So you can't even do continuous commissioning, right, without asking them. And then you have smart real estate, and we have a slide for that as well. Smart real estate, I think, is probably where you see the most investment and adoption, because it affects people that matter, like the users, the employees. The most expensive guys in a corporation are the employees, right? And then I put in light bulbs and sales guys. So I think, from my observation, like working in design and spending a few years at Skanska and now working with facility management teams and operation, I think most of the innovation in the architecture and engineering world is organic in-house. I think it's extremely difficult to be like the smartest BIM guy with automation tools and sell services to throw into Mercedes, because they'll just do it themselves, right? So I think that's just the reality. The A&D, smart guys, love to solve problems, lots of in-house organic innovation, and it's good that way. Not so much in construction. That's where sales guys come in, and a lot of stuff is serviced out, because it's just so much more fun to just manage things, and then have users not use the technology the right way. And it gets worse towards operation, right? So the screen is not quite synced the right way, but so I give it one light bulb, and I think I'm generous with that. The other thing is the O is like it's actually should be 3 O's, right? Because there's a big difference between occupants, operation, and ownership. They're different people, different interests, different data sets, different compliance things. And then there's also the footprint of what you can do with change and innovation, how much impact you can have. So there's like, I have a little impact, a medium impact, and a large impact, and I already mentioned that earlier. The largest impact comes from affecting like healthy, productive, comfortable millennials, right? They all want to work in Google and WeWorks and have a barista and have super nice, comfy space, and corporations feel the need to compete to those standards. So we'll see in the next 12 months, maybe there's a little more of a reality check coming now. But there's a study from, was it McDonald's and JLL? And JLL redid their space in Chicago or something like that, right? And it's super nice. So very expensive, lots of investment there, lots of automation. The one in the middle is the topic around preventative maintenance and strategic placement of capital for maintenance. So if you listen to equipment and you see in the data how stuff gets bad, and you can plan repair rather than react and always put out fires and be 2 weeks late. And then the smallest one is, and that's the irony, like we all like, oh yeah, we're going to use technology to save energy. If you look at the guys that operate companies and buildings and portfolios, the energy saving is peanuts. It just doesn't move the needle. So we have little energy metric symbols down there on the right. So we're one of these technology providers in the O space, and we're focusing on the smallest problem, the energy savings there. So we've worked. Energy Metrics is a small company in New York since 2009. We did a lot of instrumentation and working with building management systems. We did a lot of monitoring in data centers. Worked very closely with clients up in Canada, financial clients. So we did a project with them for their bank branches. So what we're talking about is not like the built environment and operations and facility management. We're just talking about these little things with the ATM's bank branches. So we're going to put thermostats and lights connected with a cloud platform and dashboards and a web application. We're going to put that into your bank branches, and that's going to save you money. So we want to just so let's be an IoT company, right? So let's realize that the Raspberry Pi is not going to cut it, because you have to be able to update firmware automatically. You have to be able to remote monitor and access your devices. If you think you can just get on your customer's Wi-Fi, not happening, not in a bank anyways. So you have to bring your own telephone. So now we're talking data plans, And by the time you're done like doing hundreds of branches, thousands of pieces of equipment, your influx of data is becoming a problem, and so you need to think about scale. So we did some proof of concept with them, POCs, they're great, to study use cases, we've heard that before today. And the other thing we've learned over the years is don't think that the proof of concept, like that you rip it out and you get another chance to do it again. Proof of concepts, they always stick around, like the data that you get wrong at first is gonna be wrong, like because it's not going away, right? And then I have that here, which part do you wanna play, like who's your customer? Because in the case here with banks, so the banks are the owner, but they have a management team, like the CBREs, the JLLs, and they're a different company. And so who's your customer? Is it the facility management team, who's ultimately doing stuff more efficiently, for instance, or is it the bank, for instance? So we started out with a cloud-based platform, if you wish, where you can connect the devices, ingest real-time data, and we're like, that's great. With an API, of course, now engineers can start to build their applications on that and service owners. Didn't happen. It's like build it and they come is obviously, that only happens if you Apple. So we figured out our use case and we built connectors to Ecobee thermostats, light switches, power meters, and kind of really nailed that over time. And then we're like, and now somebody else is going to manage the project for you. That's also not happening. So we're also managing the projects now. So we're like, we're getting to the bottom two boxes here, where the question now is which part is product, and TT Core is kind of like dazzling in that, like which part is product and which part is service. We're all really good at service because that's how our industry works, right? You get paid by the hour, and that's how you measure how much stuff costs. But in a product, it's like, oh, we're going to have this thing. You're going to get SaaS charges, and it's just going to scale, grow, and it's going to be continuous revenue, right? What you need to keep in mind on the product side is you need to design user interfaces for self-serviceability. So you have to spend a lot more time on like what are users actually going to do with that. You need to be able to enable partners. So you don't want to like do all this stuff yourself. If you want to grow, you have to enable other companies to do this kind of work and project for you. You need to figure out how and what you charge for. Documentation and support is something that is, it's kind of like understood that that's part of the deal, but no engineer has that like on the radar when you start making a project like that. So that's where you have, and you want to have a great demo environment, right? And if you think about it, every one of these bullet points could be a team of 4 guys. If you want to be like an R&D department with unlimited budget, you can put a lot of people at work to do this and do it right. And obviously it doesn't work like that in a small startup environment. Service is, with our customer now, we have different project phases. So they release budget to do a little bit now, and a little bit in a half year, and a little bit half year later. So you need to itemize this stuff by project phases. You'd identify like which banks do you want to go to, like which are your like low-hanging fruits, for instance. Scheduling of contractors, tracking inventory, paying and getting paid. We work in Canada, same thing here. You have different tax rates in different provinces. So when you invoice a facility management company, for instance, you'll have to apply different multipliers on taxes, and checking that into what is supposed to be an IoT engineering application to do energy management, it's like you didn't think about putting taxes in there. And then you have 1-800 like help, it's broken, so you need to be able to maintain it. So where we're getting with that is we have this product that we had in mind building, and then we spawned a whole operation of tracking project management, if you want, that is almost its own animal. Like we completely underestimated how much effort would go. There's a lot of effort obviously going into the product, but then there's a lot of effort going into project management. And you start out junior guys, Excel, and then like a few hundred branches later, you find out that these processes don't work. And that's very similar to the time back at Skanska, where everybody operates this stuff out of Excel. But then you have cubes, you have multidimensional data, you need interoperability, so you back square one, like need to automate stuff. I think multitenancy is a big one, because you could say like, oh, you just put it, we also had that earlier, you put it in a database, build a little web front end, but then you need to like these role-based things, like who's allowed to touch what in a web application is really difficult. And what we also get, since we do have that stack of data now, we get all these reports like, oh, can we have a list of this? Can we have a list of that? And we're like, well, those reports are already in the product. But then they want it in Excel because they always want to shove it a different way, right? So a quick intermezzo here, lesson learned 102. There's much more to IoT projects than just the technology. We find that as we continue to develop the data sets that are needed to do the project management, like we couldn't just tell someone else to do this project for a different bank, and then they'll start all over with Excel. We feel like having figured that one out, it's almost like a product in its own right to enable other partners to do likewise projects. It's a bit ironic. So the portfolio owner, the bank, and the facility manager, they boast there's no such thing as like a list that is correct about how many branches they have, where they have them, what the operating hours are, and what the correct address is. So we find ourselves like taking lists with like 3,000 branches and fact-checking them against Yelp and Google APIs. So now they're getting wind of that. We're really efficient in doing that, and now they want in on it. So in Yelp, you can go like, well, if a branch is closed and somebody drove there, and you have really old, stale reviews, for instance, is an indication that the branch is not really active, right? Whereas if you have somebody got terrible service yesterday, you know, like, yes, it's a bank, but yes, it's open. And then I have one here. The conflicts and incompatibilities observed are very similar to BIM issues, which is who gets to build it, who gets to pay for it, who's allowed to do what in this space. That's exactly the same in facility management, because it's not just the owner and the FM teams, right? Everything's outsourced. There's different companies doing different stuff, and it's exactly the same hurdles that stop like integrated project delivery, for instance. So I've read a few recent, really interesting publications. One is Phil Bernstein from Yale. The other one is the CTO of Schneider Electric, if you want to look it up. And they're basically now starting to review what they feel is like 10 years of all that innovation and project process that hasn't happened, right? So data centers, for instance, we work in data centers. There's this technology, DCIM, Data Center Infrastructure Management, which is exactly that. It's integrated facility management, but specifically for data centers. And they were like, it's going to be a bonanza, $5 billion market, you know? And they've been investing for 10, 15 years, companies, and the adoption in industry is almost zero. So it's like you're almost looking at a lost generation of like 15 years of progress that we could have made that we as an industry haven't made. So look that up. I'm going to hand over to Jonathan. I'm going to explain how the clicker works. That one. That's the one you want.
That one?
Yep.
How good it works. Well, good morning, everyone. I got a couple of minutes, so we'll buckle up and we'll blast through this. But a quick show of hands. How many people here work with buildings? Oh, good, I'm at the right symposium. But let's keep those hands up if the average size of the building you work with is less than 10,000 square feet. All right, so we'll catch up later. So why don't we really touch them? I mean, small buildings, they account for a large portion of the building population. But maybe the reality is there's too many of them. It's hard to scale engineering at that level. And if you're trying to save like a 20% energy reduction, it's probably peanuts, as Gregor said. So why bother? They're probably small enough you think maybe they're well behaved and organized and we know where all the issues are, kind of like the picture over on the left. But maybe the reality is more it's like the one on the right where it's just a mess. And ideally what we want to get to, we want to get a performance chart like this, where we can see all the sites and understand their performance, which are the poor performing ones, which are the ones that are trending good or bad, maybe on a quarterly and annual basis. And the idea is we help green stay green and red become green. And I like these, and these kind of highlight the IoT project over the last couple of years from when we got the portfolio to where we are now. And I have a few slides later on performance. But what I'll do is I'll blast through kind of like what's the engineering thought process and kind of why we go through the 8 parts of project management to get to the 2 parts of the IoTini. So more or less the high level of the engineering thought process. It always starts with collecting data. IoT devices, they're cheap, they're easy, they're foolproof. And that's awesome, because usually when we show up at a site, we don't know what's there, and it's not us that shows up, it's a contractor. And they just need to understand, like, well, how many rooftop units are there? Property managers don't often know that. So they show up with their briefcase, easy devices, they go in, they install, they survey, they're in and out in a day. Unfortunately, we have to leave the BMS controllers behind because it just doesn't scale that well. And the biggest challenge there is field installation. Like, if you're setting up the devices the wrong way, well then you're going to get bad data, and the report sucks at that point. So that's critical. And then IoT is a crowded space. Different vendors, different silos. The big challenge is centralizing the data, and we have to put a repository around it. And then you got to contextualize the data. So it's not just telemetry, it's relational, like what's where, geospatial, where is it located, transactional, what are the bills and the service tickets behind it. And the orchestration of all that is going to drive your ROI. So challenging enough on a large building, now in a smaller building where you have to be efficient, that's where it kind of gets dicey. And we can get into analytics, and it's fun and everything, but the reality is these are the, oh, too far. All right, so there's the trailer of the presentation. But back to analytics, like, that's fun, we have data, what can we do? It actually turns out there's common sense first. Thermostats are not set up to operate correctly. Like, hey, I have an occupied schedule on a Sunday, which is not necessarily good, but in this case it's actually pretty good because the technician set up unoccupied heating set point higher than occupied. So hey, we're still saving energy. But how do we prevent this? What does analytics become? And it becomes more or less a policy enforcement, applied and rolled out and automated across a portfolio of small buildings. Where if we're occupied, we're maximizing comfort. If we're unoccupied, we're maximizing energy savings. Both at reasonable set points and settings. And objections are, well, I have too many devices, because we're over 3,000 devices deployed. Define, someone please, reasonable. And then it's a small building. So back to the first point, energy savings are peanuts. So why go through the trouble? So first thing is, now that we're collecting all the data, we want to find the needles in the haystack. So we want to bubble up the data. We want to show where it is. We want to find out who put the needle in the haystack to begin with. And it turns out all sustainability practices, we talk about it at the engineering level and the CEO level and so forth, but when it comes to the boots on the ground, are they really trained to do that? So you can actually see here is the audit report from the user that actually set the thermostat that way. And I can do one of two things. I can either reprimand, or I can use it as an education opportunity. Again, we don't want more needles in the haystack. Great, I found the problem. I want my thermostat to operate like this because this is the ideal schedule. I'm not going to drive a truck or a van out there, it's too expensive. So with IoT, I need to leverage remote capabilities. Because truck rolls cost money, technicians cost money, consultants cost money. So it's all about automation and scaling at that level. So where does analytics go to? Kind of like taking a step back and looking what we've done over the past couple of years. Well, the ML and AI, we're happy to collaborate with third parties. Best example is Smart Startup on the thermostats and devices. But the reality is analytics sticks to the basics. It's all about policies. It's about policies around comfort, maintenance, energy, and being able to close the loop and provide means of remote fixing, provide means of automating for the unicorn, really. And by the unicorn, if anyone here knows of a facility manager with a master's in engineering, LEED certified, and kind of tech savvy, please let me know. And that's kind of why we're stuck to the basics. We're dealing with a cultural change in an industry that is more traditional, yet modern IoT wants to push into it. And it's all about scale, small buildings. If I do it for one, can I do it for 10, 100, 1,000? It's a little bit added up. So what does that look like at the end of the day? So just a quick snapshot of where we are with the project. Every dot over here on the map is where we're installed, color-coded by efficiency, over 570 plus sites over the last couple of years. That's more than 3 million square feet of managed real estate, energy savings over 1.3 million. On an energy ROI, it's less than 3 years. What we came across by accident is because we're avoiding truck rolls. When you consider maintenance, the ROI drops to less than a year, which is pretty insane. And then you factor in the biggest expense, occupants, productivity. Anytime there's a comfort call or it's too hot, it's too cold, we're taking the resolution time from days or hours down to minutes. And that's something we haven't quantified yet. So what do we learn from here? Policy-based analytics first, then automate them. We'll use whatever ML, AI that's around and just scale it up. Energy is always the starting point, just because you have the utility bills. But at the end of the day, the maintenance, the truck rolls, that's huge. Comfort is huge. In terms of computing and maintaining ROIs, it's a delicate balance, and one that has to be automated. Energy is pretty easy. ASHRAE's got a ton of guidelines behind it. Maintenance, a little bit more manual regarding billing and invoicing and tracking hours for technicians and truck rolls. So that's still working there. And when it comes to comfort, well, maybe next year I'll tell you how that looks like. And then for us, we did it in phases. It was actually really good because for the client, it's less capital up front. The savings for one phase propels the second phase and the next phase. But site selection is very critical. If you have to be good at ROI forecasting. So it's a little bit of Monte Carlo, a little bit of energy simulation, making sure that phase one saves the biggest amount of money it can possibly save. And it's a great shakedown for the team because ultimately it's that 8 parts of project management that you don't expect. And yeah, we all think the IoTini is 8 parts project management, 1 part connected device, 1 part cloud orchestration, and sadly only a dash of analytics. So with that, I want to thank you for your time. Yep.